Okay. So before I get started, I would like to say that the topic is aircraft development and certification challenge for new technology insertion. So the paper or the concept is at the very beginning. So it is very conceptual at this moment, but I really like to share that with the audience. And I'm really sorry I couldn't attend the conference because I really like to visit Toulouse. Anyway, today I want to say a little bit, I will start with the introduction and then current certification process. So an emerging aerospace technologies timeline and a little bit of analysis of single pilot operations. And then I would say what I'm going to develop, I mean, the methodology and framework, and then conclusion. So as you may know, the new technologies have always been the driving factors for the evolution of modern aircraft. And in parallel with the implementation of the products, the process of verification and validation of the designs has resulted in standards to define the process of certification and to provide a basis on which aircraft and development, design and development can proceed to produce safe designs. Along the way, some steps change the technology applications have been known to result in issues to route to the certification. And some examples you may know are like the introduction of real-time software in safety critical systems, FADIC, fly-by-wire flight control systems, glass cockpit, composite materials, and unstable aircraft configuration, and introduction of ETOPS. These are the issues that have already gone through the certification and got certified. The next slide shows the increasing sophistication of aircraft systems over time. So as the particular things that I would like to emphasize is the functional integration and integrated systems that have been introduced in aircraft development, and particularly aircraft system design. So what it's going to highlight is that we do need a mechanism to scrutinize the design process. Further, as we saw in previous slides, we have already implemented some new technologies, but there are likely that more technology changes are due to proposed for the next generation of aircraft, and some of these have already been researched and trialed. For example, the virtual cockpit, or passenger carrying unmanned aircraft, or autonomous operations in controlled airspace, or the use of virtual reality to validate maintenance actions. So as we know, none of these are to be insurmountable, but it is wise to identify the difficulties in advance to reduce risk and to avoid program delays. This is especially relevant to if the changes to standards or the certification process are likely to occur. So currently, the current certification process is like this. So we can categorize it into 3 steps: TC, or the most famous one, which is type certification. The next one is production certification and airworthiness, and the last one is airworthiness, or which is known as continued airworthiness. By type certification, we mean which is related to the design phase. Production certification is the confirmation of assembly of aircraft, and airworthiness is what is mostly known as continued airworthiness. In design and or type certification process, it includes the concept design, requirements definition, compliance planning, implementation, and manufacturing. So what is going to be highlighted in this work is the level of authorities' involvement in design process. In the TC, it is more likely to be informational and providing the designers with some guidance materials and procedural technical requirements. In the requirement definition, the project is outlined and given to the authorities, in which the initial designs are reviewed and initial certification basis is defined. Further, in compliance planning, the authorities verify whether compliance and conformity are met. The implementation phase is comprised of data generation, substantiation activities, and findings. The compliance activities is carried out at system level and aircraft level. At the subsystem level, as the subsystem starts, the actual testing of the project is introduced. Actually, the source of data generation is test and analysis, and the authorities in this phase look to if the design data is met the intended requirements. And the last phase is manufacturing and post certification, which are as continuous process among authorities and OEMs. This is current certification process in brief, as we all are familiar with Part 21, and particularly even EASA-based one. And the other factor which is important to identify is the emerging aerospace technologies timeline. So in the upper picture, you see a very basic concept generation of a system design process, which it starts from customer requirement and concept study, and it would generate different concepts, and then we would have a trade-off selections till we down select the proposed one. But in the meantime, for a single pilot operation, for instance, we do need to identify the technologies that are most likely to be used. For instance, AI or autonomous operation, virtual reality, augmented reality, and other physiological sensors, and any other new technologies. So this is what we call what I'm going to investigate, the most promising technologies that are going to be used in this concept. So as we know, the single pilot operation since 1950s, commercial aviation has reduced in number of crew, which is Harris in his paper called decrewing, has been enabled through advances in technology. And we know that we used to have more than, almost 5 crews in aircraft, but it has been decreased to currently 2. The concept of single pilot operation is to reduce the number of the crew to the 1 pilot. Here, I just want to it needs to be viewed in many aspects, such as technical, training, operational. But here I would just like to mention one example, one of the big challenges in single pilot operation, which is called pilot incapacitation. In Cranfield group design, we somehow brainstorm what we need to develop for a pilot incapacitation in single pilot operations. For instance, we said that we need equipment that aircraft with a system for monitoring the pilot's vital signs using non-intrusive sensors to monitor, for example, heart rate, breathing, pupil movement, or to provide a regular stimulus which demands a pilot response. We need to measure these inputs and provide a warning should any deterioration be detected. This warning should alert the crew, one of the cabin crew, to a senior member who is authorized to override the flight deck and door security. And then this system should alert the ATC, and the aircraft should be able to change to a kind of RPAS or remotely piloted control, and the ATC would be able to land the aircraft in a suitable field. This was just the one example of the challenges of single pilot operations. As I said, there are many challenges to implement single pilot operations, and it has to be viewed from many factors like operational, technical, safety, training, and certification, and human factors. And it is unlikely that all the organization in the aerospace industry will accept a single unified process. What I'm going to develop is the overall concept or the overall methodology is, first of all, to identify the potential technologies that is going to be used in the single pilot operation process. And then the technologies will go through a particular method or methodology which would start from technology assessment, then technology infusion assessment, performance index, safety assessment, and consumer perception. So each of these may need a long process, but generally what I want to develop is to develop a tool that would somehow automate the process of certification as well as optimize the process, because a lot of technologies have already been inserted, but they needed a rework and cancellation or stuff like that. That's why we need a kind of method and or framework to automate and optimize the process to get everything certified in aircraft. So in conclusion, safety has always been the priority in aviation industry, and airworthiness certification is a way to ensure that an aircraft has been designed, tested, and built according to regulatory requirements. Meanwhile, new technology insertion raises new challenges to get the certification. Currently, there is not a clear method and guideline on how to insert new technology into aircraft while meeting their regulatory requirement. So one example, as I said, is SPO, where the intent is to decrew the commercial airliner to single pilot operations. As you may know, based on Part 21 and CS 25, the minimum flight crew for commercial airliner is currently 2 pilots. And in addition, new technologies can help increase the level of autonomy in which contribute to SPO. As I said, the under development method is to propose a way to facilitate the certification adaptation in case of new technology insertion. So the intent is to provide a general method for new technology insertion, but the first one is going to be analyzed for single pilot operation. Thank you for your attention.